Hello and welcome to this first video about AKDL. It's about a tool which helps you defining your syntax if you need, for example, to create a new programming language or just to parse a string with a specific syntax, for example, as SQLs or numeric expressions, or logical expressions, or something else. All you need to parse would be fine with this tool. I prepared a little example just here, where I would like to parse an expression, an arithmetic expression, and evaluate it. So right now I just don't do anything in it. I have an argument which is a string, and well, I need to parse that. If I run this code, we will see the kind of expressions we have, more or less complicated, but for human beings it's rather simple, but right now the program cannot begin anything with that. So we have to define the syntax of an expression, and we hope we'll get the corresponding code to parse that, and then we can evaluate it. So let's start with our tool. Here we start from scratch. We select the new item, and here we get this screen. In the middle we have a node called root, and on the left side we have a properties area where we can just rename that. Let's say arithmetics, and here it is. We will define arithmetics by adding a keyword we will call expression. And it goes that simple as that. Now let's define our expression. What is an expression? It can be defined in different ways. You maybe have yours, but the one I prefer will be to say an expression is a term followed by a term operator followed by another expression. So I will say here term, and then I add another child keyword term operator, term op, and another keyword expression. And here we see our expression is already defined above. So it's here a reference to it. If I double click on it, I go to its definition. I find that quite interesting, because we can define some loops without looping. Yeah, it's a kind of graph. Yeah, our tree is a graph because it has the possibility to define a recursive, to have recursive definitions. So what we forgot here is those two are optional. An expression can be just a term. So I will wrap that with an operator, option, and here it's well defined. Our expression is a term followed eventually by a term operator and another expression. can click on this check keywords consistency button, and here I get some information that I didn't define term, neither term nor term operator, of course. So let's do it. Defining a term is another keyword. A term is a factor followed eventually by a factor operator followed by another term. So let's say here factor, and this time I won't forget my operator option, and within the option I will add a keyword which will be a fact operator followed by another term which is then also a keyword that will refer to the already defined term. So now, what's a factor? That's the last step of our definition. A factor is, sometimes it's an expression within parentheses. So I will call it parexp, and I will define it as first we'll have the character opening parentheses, and then we will have a keyword expression, and at the end we will have another character closing parentheses. So that's our parexp object. But a factor can be also a numerical, or let's say a numerical. I will call it num. And here it is. Oh, a factor is either this or that. It's not both. So I have to say, wrap that with the alternative operator. So it's either this or that. And here it's well defined. We still need to define our operators. Okay, so we begin with this one. A term operator is a plus or a minus, yeah? So we can do it, for example, by adding a char plus and minus and an operator alternative between those. Or better is to use this enum operator and to say the first element will be called add with the value plus, and the second element will be sub with minus. Okay. Now I can copy that and paste it here. So I have my enum here, my enum elements. I just have to rename them, because a factor is either a multiplication, I call it so, with a star, and the other is a division with a slash. So now keywords are defined. Okay. But still, we cannot generate our code because we need to add some more information here. Of course, the destination where we want the code to go in. So let's go here and say, well, that will be my destination. So just pick up the path here, paste it here, and here I'm able to click on this button. So now, well, just call go and our code is generated. What we see here is we have a separation between the parsing code and the runtime code. There are in different packages, and what we see also is for each keyword we have for both the runtime code and the parsing code we have separate classes. Okay, so if I just refresh that, I see my code here. Well, now I have some concerns. For example, my factor is a parexp object or a num. That means if I want to evaluate that, I have to decide which of those is the right one. To decide, I will ask if this object is null. If it is null, that means the other one is the right one. Okay, that's possible, but it's not that elegant. I would say there are better ways of doing that, and I will show you how to get something better. Just by wrapping that with a keyword. And this keyword, I will call it, for example, number. And here in my alternative, I have two objects this time. This one is a terminal node, which was now wrapped with an object. And here we have two objects at this level. And for the generator, it's much better because we are able to generate a factor as being an interface with a factor visitor. So that seems to be more complicated, but in fact we will get, let's say, refresh that. So we'll get this interface. We have to implement our factor visitor, and one of those two methods will be automatically called. So you don't have to explicitly ask which path you will choose to evaluate your code. It will go directly into this one or this one, depending on your entries. Yeah. What we also see is we can separate into different packages, but we can also change the packages to customize them. For example, I don't want to call it that as it is by default. I can say, for example, my exp parser and my exp rt. Well, that's not a good idea. I mean, the good idea would be to do that at the top level. If I do it at this level, it will be propagated to the whole tree. So that's a better solution. So if I say here and my exp rt, it appears also here and there. And everywhere. Yeah. So now I can also add some more structure to this code. For example, this one I will put it in this sub package, and this one into the same. I will gather all operators into one package. I can also say, for example, my factor parser will be called factor parser, and the runtime remains factor. Well, now I generate again, and here we see the operators are in a specific package, separated from the others. For the parser and for the runtime, the same. Okay, so let's see what happens here. They are here. So those two are not necessary anymore. Just delete them. And here we have our code. So we can start to parse our argument here. The entry point is arithmetics. So let's instantiate this one. Arithmetics. Let's say art equals new arithmetics, string reader, new string reader. Okay, and now we can call parse. We can also ask if parse is okay, then we return something. Art get arithmetics, and here we get the runtime code. And in this runtime code we have an expression. And we want to evaluate this expression. So we have to call a method called we will say return evaluate expression. Oh. So to evaluate our expression, we just need to look this expression as a term. So obviously we will have to evaluate the term. So let's say double result equals evaluate term of this term. And once we have our term result, if expression as a term operator, we will switch expression get term operator to either add or sub. And in the first case, our result equals, I will say plus equals, evaluate expression of expression dot get expression. And here we will have something like result equals this expression minus this. So you understand how it works. At the end we return the expression, the result. I have jumped to the already completed solution. I will maybe comment this, and we see here what we began to do and how it goes further. With the term evaluation, we do pretty the same. We say the result is evaluate factor, and if we have a factor operator, if it is a division, we divide result through the evaluation of the next term, or if it is multiplication, we will multiply it. And the evaluation of the factor is just creating a visitor implementation, which is here, and calling accept. The accept method will visit either this or that. And in each case, we will do our corresponding evaluation, either by calling the number directly here, or calling the evaluate expression method, which is declared above. This one. So, and if we run that, we just get our result. You can check. I think it's okay. What I commented here is to show that it's also possible to call a part of the parser what we have. So that means this one, the factor parser will be instantiated here, and instead of doing an evaluation, a complete evaluation from the top of the node, if you want, we can just focus on this factor. So I have just picked up the last element here, and I put it into parentheses, and you remember a factor is an expression within parentheses. That's why I did that, and I just call directly evaluate factor by calling the factor out of this factor parser. So that means it is possible to make some partial parsing, because we have different entry points here. We have not only one main entry point, but as many as we want. And in this case, it also works. Of course, we have to pass our string to the main, but afterwards we just parse partially. We don't need to parse the whole source, if you want. We can just parse a snippet. That's the purpose of this. So if we now run that, we see at the end, we have the same result. So that's it for this video. In the description we will find the links to the GitHub where you can download this tool, and see you on the next video. Thank you for watching. Bye bye.